today by reviewing what you did in your group this week. And then we'll follow up with some independent math questions you're going to do on your own at home. This week, math groups all had a meeting with me to talk about tree diagrams, which are a great way to organize combinations of things when we are looking at the probability of different events happening. A tree diagram helps us to organize our thoughts, and I showed you a way to do it that is very organized on a page where things have a particular order and things are lined up into columns and even rows, which helps us to organize our thinking. A lot of you noticed that you could do some mathematical things in your mind as a shortcut to tell you what kinds of combinations there were going to be. But like I said in the group to everybody, it's really important for everyone to learn how to create a tree diagram when we're first learning to do this. So even though there's a shortcut, we're going to do the long way first in order to make sure that our thinking is clear and organized. Here's a review of the question that we did in our groups this week. It was a story about a boy who is a soccer player, and he was randomly choosing a shirt, shorts, and socks from his drawers in his dresser, but he was doing it in the dark, and he was therefore choosing random colors of shirt, shorts, and socks. He only had 2 choices for shirts, black and white, and 2 choices for shorts, black and white, and he had 3 choices for socks, white, purple, and green. And we talked about the fact that we could look at that list of items and colors, and we could go back and forth between them and figure out eventually what a lot of the combinations are. But we also talked about the fact that if we try to just do that in our head or just kind of randomly looking at the list and picking things here and there, that there's a big possibility that we could forget something or we could duplicate something. So that's why we used a tree diagram. We put the shirts in the left column, shorts in the column beside that, and then socks, and then all the combinations are on the far right. We discovered that there were 12 combinations, and some of you came up with a short form for that, like a shortcut, which would be a great level 4 addition to any answers that you might do after drawing your tree diagram. I wanted to show you that tree diagrams can also be used for questions where there aren't a lot of options. So just to quickly review, those shirts, we had black and white. The shorts, we had black and white. The socks, we had white, purple, and green. And so we had, multiple options for each category. The question that we're going to look at right now doesn't have multiple options per category. In fact, it only has 3 categories, and each category only has 1 option inside of it. So let me read the question. Mr. Rowe has cards labeled 1, 2, and 3. He arranges the cards to make a 3-digit number. What is the probability that the 3-digit number is less than 200? So using our reading strategies, we are going to highlight the important information. He has cards, and they're labeled 1, 2, and 3. He arranges the cards to make a 3-digit number. So he makes a 3-digit number. And the final step is asking us what's the probability that the 3-digit number is less than 200. And I'm doing that in a different color because I want to focus on what we're highlighting in yellow first. Another great strategy for understanding a question, is to summarize what the question says. And we can do that with a list of words, or we can do that with pictures. So I'm going to start again at the beginning. Mr. Rowe has cards labeled 1, 2, and 3. So I'm going to infer that the cards are rectangular shaped. 1, 2, and 3. He's going to arrange these cards. So he's going to put them in order, and he's going to make a 3-digit number. So 1 will go here, 1 will go here, and one will go here. So we don't know what all of the different orders are. Okay, so now we're going to think about a tree diagram. Now you might think that the first column should be 1, the second column should be 2, and the third column should be 3. But for this question, the columns, which are the events basically, are which is going to be the first number, which is going to be the second number, and which is going to be the third number. Okay, so this column will be first number, the next column, second number, the last column, what is going to be the third number. And just like I did in your math group, I'm going to kind of make columns with that. Okay, so the first thing is I'm going to start with the first number, and I'm going to start actually with number 1. And I'm going to say to myself, if number 1 is the first card, what are the options for the second number? Well, it can't be another 1. It has to be either the 2 or the 3. So my choices here are, if the first card is a 1, the second card might be a 2. Or if the first card is a 1, the second card might be a 3. And those are the only options there are. What if my first card is a 2? If my first card is a 2, what are my options for second number? Well, there's only 2 other options. The second card could be a 1, or the second card could be the 3. And what if my first card is the 3? What are the second number options? Well, the second number could be a 2, or it could be a 1. All right, now let's go to the third number. If my first card is 1, follow the branch, and my second card is a 2, what is my third card going to be? Well, there's only one left. So if that was the case, the third card would be the 3. If my first card was a 1 and the second card after it was a 3, what card would be my third card? Well, the only option would be the 2. All right, well, how about if the first card was a 2 and the second card was a 1? What would the third card be? There's only one option. It would have to be the 3. And if the first card was a 2 and the second card was a 3, the only option for the third card would be the 1. If my first card was a 3 and my second card was a 2, the third card would have to be 1. If my first card was a 3 and the second card was a 1, my third card has to be the 2. Okay, so now we're ready for our final combinations. So we'll call this column, well, they're not combinations. What would we call them instead? All the different possible orders, and that being orders of cards. So we follow the branches through. I'm only going to highlight one of them because it takes a lot of time. So the first combination is going to be 1, 2, 3. The second combination would be 1, 3, 2. Next combination would be 213, then 231, 321, and 312. So you might think that you're finished and that you have answered the question, but we still have to answer the last part. What is the probability that the 3-digit number is less than 200? So we're going to look at all of the numbers that we made by ordering those digits, and we're going to choose the 3-digit numbers that are less than 200. 123 is less than 200. 132 is less than 200. 213 is not less than 200. 231 is not less than 200. 321 not less than 200, and 312 not less than 200. So the only options are these two. What is the probability that the 3-digit number is less than 200? Well, there are two of them. 2 are less than 200. Out of a total of, let me number those, 1, 2, 3, 4, 5, 6 different combinations. So 2 out of 6 is the probability, and the 6 would be the total. As I pointed out in our meetings this week, it's important for us to reduce our fractions. So I ask myself, is there a number that divides equally into 2 and into 6? And the answer is yes, there's a 2. So using equivalent fractions, I come up with a final probability of 1 out of 3. So the probability that the 3-digit number is less than 200 is 1 out of 3. I'm not going to take the time to write that final statement, but you would write a final statement. The probability that the 3-digit number is less than 200 is 1 out of 3.